Now that we can recognize intermolecular forces, we can look to see if things will actually mix together. And what we know is that solutions will typically form when the solute and the solvent have similar intermolecular forces. And this similarity, we typically talk about the fact that like dissolves like, meaning that if the solute has similar intermolecular forces to the solute, it will probably dissolve. And so let's just talk about some quick definitions. A solution is a homogeneous mixture of two or more substances, and this mixture can, of course, be a solid in a liquid, or a liquid in a liquid, or gas in a liquid. The solute is the substance that's dispersed in the solution, and the solvent is the substance doing the dissolving, and it's usually present in the greatest quantity. So, for example, a good solvent is water or oil. And so, if you looked at a beaker with which had a solution in it, you would see that there are lots of blue, purpley solvent molecules and a lesser number of solute molecules, the red ones. But they're all equally dispersed in a solution, and that's the important part. And so, when we talk about will they mix, if we look at two molecules here, so this is ethane, which is a hydrocarbon, so it's a bit like an oil. It's a gas, but it's based in a hydrocarbon. This has London dispersion forces. So the interaction between ethane and another ethane molecule would be London dispersion forces. And the water molecule is a polar molecule and has hydrogen bonding. And so this water molecule is going to be attracted to another water molecule by these strong attractive forces. And the ethane is going to be attracted to another ethane by London dispersion forces. Now, if we were going to dissolve ethane in water, in order for that to happen, the ethane would need to be more attracted to the water molecule than the ethane is to another ethane molecule. And if that's the case, if ethane is more attracted to the water molecule, then it will dissolve in water. And so that's what this says. A solute, ethane, dissolves when the attractive forces between it and the solvent, so between it, ethane, and water, overcome the attractive forces between ethane and ethane, and also between water and water. And so, in order for that to happen, typically the solute and the solvent have to have the same types of intermolecular forces. And in this particular case, they don't. And so, therefore, the attractive forces between water and a water molecule will not be overcome by the attraction of ethane to water. And how do we know this? Well, we can recognize this as a non-polar molecule, has London dispersion forces. Water is a polar molecule, has hydrogen bonds. The intermolecular forces are not the same between the two, and therefore they are unlikely to mix. So let's just take something like a glass of wine. If you take a glass of wine and you wanted to add some water or some ice to it, would it dissolve? And so the question really comes is, will these two compounds mix? Will they mix? And the most important thing at this point is to say, well, if they have the same intermolecular forces, they most likely will mix. So we know that water, this is immediately why we're able to draw some nice arrows to show that this has a dipole, and we know that it has a dipole, and then we look to see if H is bonded to NOF, and it is, so this has hydrogen bonding. And if we look at ethanol, which is a more complicated molecule, but if we look at these bonds here, these carbon-hydrogen bonds, these are non-polar. However, over here we have an oxygen bonded to a hydrogen, which does form a polar bond. A carbon bonded to an oxygen also forms a polar bond. So this is going to be negative, this is going to be positive, this is going to be positive. So it looks like this has a polar end to this molecule. And then, because this is the case, we would also ask the question, is hydrogen directly bonded to NOF? And indeed, it's bonded to oxygen. So this is an example of hydrogen bonding. And so now we can actually ask the question that we were originally intending, will they mix? Well, water has hydrogen bonding. Ethanol has hydrogen bonding. They have similar intermolecular forces. Yes, they will mix because they have similar intermolecular forces. And so, because they have similar intermolecular forces, they will mix. So, we could say, well, sodium chloride, table salt, does that dissolve in water? Well, we all know it does, don't we? But why does that dissolve in water? Water, which is a polar molecule, and sodium chloride, sodium is a metal, and as soon as you see a metal and a non-metal, you're going to say, oh, this is an ionic compound, and an ionic compound, which is made up of sodium ions and chloride ions, these ions are charged. Because they're charged, they will be attracted to something that has a negative end and something that has a positive end. And so it just so happens that the water molecule has a negative end and has a positive end. And so what will happen is ionic compounds, many ionic compounds, will dissolve in water. I'm just going to put many ionic compounds will dissolve in water, because what will happen is the sodium ion will get attracted to the water molecule and will get surrounded by the water molecule from some type of attractive force. And we need a name for this attractive force. Well, in the middle we have an ion, and on the outside we have a dipole. So these are called ion dipole attractions. And exactly the same thing will happen with the chloride ion. So here's the chloride ion, but it's going to get attracted to the positive end of the water molecule. Also by ion dipole attractions. So will table salt dissolve in water? Well, because it's an ionic compound, and many ionic compounds will dissolve in water, and they'll dissolve by ion dipole attractions. And this is what ion dipole attractions look like. A positive in the middle attracted to the negative oxygen of the water, or if it's the negative ion, it's going to be attracted to the hydrogens, the positive end of the water. And so ionic substances will dissolve in water through ion dipole attractions. And so, if you were going to use some cement in some type of application, you would need to make the choice of what solvent would you mix the cement in. And you typically, mix cement in water, with water. And why is that? Well, cement is a mixture of calcium oxide and some silica oxides and some aluminum oxides. And of course, all of these are made up of ions. And these are all made up of ions. And these ions will dissolve in water. Why? Because of ion dipole attractions. Because the ions that are formed will be attracted to the water molecules, and so they'll dissolve in water. So water is a particularly good solvent. It's a very common solvent. It's a polar solvent. So polar solutes will dissolve in polar solvents. So water is very good for dissolving polar molecules. And many organic compounds are polar as well. And so let's just take as an example acrylic paint. So if you were going to do some painting at home, you would use acrylic paint, and acrylic paint is based on acrylic acid. And if you look at the molecule acrylic acid, which is somewhat more complicated than other molecules we've looked at, you would immediately think, well, If I look here, carbon-hydrogen, these are non-polar bonds here. Carbon-carbon is a non-polar bond. However, when I see carbon and oxygen, and I see carbon and oxygen, and I see hydrogen and oxygen, and you're beginning to see that they're always the same bonds that we talk about. So this is going to be slightly negative, this is going to be slightly negative, this is going to be slightly positive. So this molecule is going to be pretty polar. And then you would say, oh, well, is hydrogen directly bonded to NOF? And in this particular case, you would see that hydrogen is bonded directly to oxygen. And so there would be hydrogen bonding here. And then you would say, well, if I spilt acrylic paint all over my best shirt, what am I going to use to get it out? Or if I wanted to dilute this, what would I dilute it with? Would I use water? Well, this has hydrogen bonding in it, acrylic paint or acrylic acid, and because it has hydrogen bonding and water has hydrogen bonding, is a polar solvent, these two would dissolve, they would mix, because they have the same intermolecular forces. So on the other hand, Banksy, who was a graffiti artist, came from Bristol, from where I came from. Not sure if I really met Banksy at any point, but Banksy is a graffiti artist who uses spray paint on walls. And so, would the spray paint on walls, would it be a good idea to use a water-based one, or would it be an oil-based one? How would you clean this off? Well, if you look at a spray paint, the main basis of spray paints are typically what's called use an oil-based form, and this is called toluene. And these are two structures of toluene. These two are identical. This is just a shorthand version. And if we look at this, you would hopefully see that there's carbon and carbon bonds, which are non-polar, carbon and hydrogen bonds, which are non-polar, 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 all non-polar. And so this molecule is a non-polar molecule. Therefore, it doesn't have a dipole. So it's going to have London dispersion forces because there's no permanent dipole. And London dispersion forces are not going to mix with something that's a polar solvent. So if we used water, it would not dissolve in a polar solvent. So you couldn't use water. No. You would need to use something else that had London dispersion forces or a non-polar solvent. And so a non-polar solvent is typically going to be some type of oil-based solvent. And there are many things such as hexane, pentane, some older ones called benzene. These are all non-polar solvents. And these are non-polar solvents which would be very good for cleaning spray paint and graffiti off walls. And so from a dissolution point of view, like dissolves like because of the intermolecular forces that are involved. And so when we talk about mixing, we always want to remember that like dissolves like. So if it's polar, it's going to be dissolved by something that's polar. If it's non-polar, it's going to be dissolved by something that's non-polar.